Woohoo! We are live. This is Math 40 Elementary Algebra, and we are simplifying rational expressions. It's basically fancy fraction time. We've been reducing, and I'll remind you that with these problems that we're doing right now, we're not required to worry about the denominator, but we could talk about it anyway. For example, anytime you're looking at one of these, you should definitely be thinking, I wonder how we could make this denominator equal 0. Like, would x equals 1 do it? Or would it be -1? So these are things you can consider. But for our purposes, what I want to do is I want to reduce. And if you remember, if I'm trying to figure out how to reduce, say, 9/12, right? If I'm trying to reduce 9/12, what do? I break 9 down. I say 9 is 3 times 3, and 12 is 3 times 4. And then I go, oh, well, cancel the matching things, right? So I get 3/4. In the same way, I'm going to factor each of these. I'm going to factor the numerator and the denominator, and then I'm going to use that to reduce. So up top, I've got a 3 times an x times an x. Basically, it's kind of already factored for me. Down in the denominator, I have a binomial. So I have to think, how would I factor this? And I see common factors, so that might be where I start. I'm going to factor out the 3. If I factor the 3 out of the 3x, I have x. If I factor the 3 out of the 3 here, I have +1. And then I think, oh, just like above, I'm going to factor the 3's out. And then what do I have left? X squared all over x plus 1. Now here's the thing. This x and this x are winking at each other. And it really is tempting to cancel. Do not cancel when there are more than, oh, I'm using bad English. There is more than one. There are more than one term. I think that should be is more. When there is more than one term, let me fix that up because otherwise this will just bug me. Do not cancel when there's more than one term, top or bottom. You have to factor. So look what we did here. I had 2 terms in the denominator, so I factored out a 3 and I realized, oh, I can reduce that. But now, can I factor out an x here? No. If I can't factor out an x, I'm done. This is it. This is the fully reduced form. It doesn't look like it, but it is. Okay. Shall we go to the next one? The next one is a little tricky. I gotta warn you. Up on top, we've got 3 minus x. Down in the bottom, in the denominator, I have x squared minus 9. Do you notice that this is x squared minus 3 squared? It's a difference of 2 squares. So we've got x plus 3 and x minus 3. And here, I have opposite polynomials. Woohoo! Opposite polynomials means I can reduce. But when I reduce these, what do I have left? I don't have exactly 1 because they're not the same. I have -1. You're right. So I'm going to use my handy dandy highlighter. Nothing bad happens when you're highlighting. There you go. I'm sorry, this is so bright and ooky. Let me see. I'll be right back. Let me see if turning on the overhead light will help. Balance it out a little bit. Oh, it adds more shadows. Well, that's what we always wanted. Everyone in video is always telling me, make sure you've got lots of shadows. Shadows are where it's at. So, opposite polynomials, cancel, and leave a -1. That was the thing we discovered on the very first page. When you cancel opposite polynomials, you end up with a negative. Now, a couple things to note about this. This can be written as -1 over x plus 3 or the opposite of 1 over x plus 3. You've got a choice between putting the minus up there and the minus down there. Woohoo? Woohoo. Shall we try a couple more? Why don't we? Dun, dun, dun. We're on the last page of 7.1. Woohoo! And this one is pretty gruesome. We have a couple of polynomials. The numerator is a trinomial, 3x squared plus 5x plus 2 all over x squared minus 1. Now, I'll tell you, I recognize down in the denominator x plus 1, x minus 1, because this is a difference of squares. Okay, so that's pretty nice. But then, maybe that'll be easier to look at. That's a difference of squares. Up here, remember, trial and error. I'm going to come up with 3x and x. And I've got a 2. What if I put a plus 2 here and a plus 1? Let's double check. 3x squared, yes. 3x, 2x, that'll give us the 5x. And then plus 2 times 1 gives us the 2. So that will work. So this problem relies on being able to factor each of these. So we factor them, and notice that this is all multiplication. As soon as it's all multiplication, you're golden, because then you could just find, like here, the x plus 1 and the x plus 1 match, and I get 3x plus 2 on top and x minus 1 on the bottom. See how that works? It's kind of cool. And if you're anything like me, I'm trying to be professional, but honestly, whenever I'm reducing fractions, I make explosion noises. So I would be like, pew, kaboom, kaboom, because I get really resentful towards fractions, and anything I can do to, destroy them, that's good for me. Okay, you want to try one more? Now, this one is going to be like many. If it suddenly seems too simple, be very careful, because this one suddenly looks really simple. And look at that. I'm back to being way too bright. I'm not sure what's going on here. I'm not able to bring the brightness down and keep it down. Whoa, some interesting stuff going on. Okay, so I've got two terms. So in order, if I do want to reduce, I have to factor. So in the numerator, can I factor anything? Yes, I can factor out a 10. So it's 10 times the quantity x plus 1. Down in the denominator, I just have a 5. Notice that the 10 and the 5 will reduce. So I cancel the 5, and the 10 leaves 2. So I've got 2 times the quantity x plus 1 all over 1. You got it. So in other words, I have 2 times the quantity x plus 1. The fractional form looks like this, but if you have 1 in the denominator, you really have more of a whole number. Now, sometimes WebAssign wants you to write this, and sometimes they want you to write this. So they're both possible answers. And, whenever you're having trouble with WebAssign, go ahead and text me or email me. If the answer won't seem to go in right, I can always look it up and see what it is that WebAssign wants to see. So that's it. You guys are ready. Woohoo. That was 7.1. Next up, we're going to do the multiplication and division and the conversion of units that I was talking about. So woohoo, rock on with your bad fractional selves.